All right, we're going to solve some equations by factoring today, and the factoring formula is going to be x squared plus bx plus c, which means a 1 in the front, which means it should not be too bad. Let's see how it goes here. First of all, when you factor a trinomial with a leading coefficient of 1, all you're really doing is you're trying to find the factors of c, which are, m times n, that add up to be b, which would be m plus n. So we're looking for factors of c, add up to be b, and that's how we're going to factor. Let's try a few here. These say factored expression. So what I'm looking for here in this first one, and really all four of these, is factors of the c term that add up to be the b term. So I know I'm going to have an x and an x because I get the x squared. Factors of 20 that have to be 9 would be 5 and 4, but because it's negative 9, I'm going to put a negative 4 and a negative 5. It does not matter which order you put them in, as long as you got them both. And the reason they're both negative is because a 9 is negative, and a negative times a negative is a positive 20, so we're okay there. On the second one here, I'm going to put the x and x again. Have a negative 12, and I need to get a positive 3 right there, so I'm trying to think, okay, 6 and 2 will not do it for me. 4 and 3 will not do it for me. You know what? There's no factors. So this one, it won't factor. We call that prime when it won't factor. Things with no factors we call prime, or just won't factor. The next one, I'm looking for factors of negative 18. That will give me negative 3. And I'm thinking 6 and 3 will do it. And because the 3 is negative, I need a negative 6 and a positive 3. So x minus 6, x plus 3. That's all there is to it, just one line of stuff. And then I'll get to the last one here. Go ahead and try to set it up, but I'm not thinking it's going to work. Let me think here. I'm looking for factors of 9, which is all we have for that is 3 and 3. And 9 and 1, and neither one of those are going to work there. So again, that's prime, or just will not factor. And that's going to happen sometimes. All right, there are two special cases. One's called difference of square. I forgot the s there, difference of squares. If you have two squares that are subtracted, perfect squares, numbers that have square roots, you can factor by doing a plus b, a minus b. For example, x squared minus 4, because they're both perfect squares, I could put x plus 2x minus 2, and that would be factored. A perfect square trinomial is when your first term and last term are perfect squares, and your middle term is what you get if you multiply together and double those. So you would get a plus b squared or a minus b squared, depending on if your middle term is plus or minus. Let me show you a couple examples there. X squared minus 49 is a difference of squares. You can notice they both have square roots. There's a minus sign. Now, let's say this. If it said x squared plus 49, you could not do this. Remember, it's called difference of squares. So I'm going to say x plus 7, x minus 7. That's all there is to it. And if you forget, you can check it using your FOIL. It should work out just fine. And the second one here is a trinomial again, like we had on the first slide, except it's special because the first term is a perfect square, the last term is a perfect square. So what I always try first is I'll try the square roots, d plus 6, d plus 6. Check your middle term. I always tell people to check your OI, check your outer and inner, and see if it gives you 12. Like 6 plus 6 is 12, so it works. You could write that d plus 6 squared because it's a perfect square trinomial. All right, what we're going to do with these is we're going to solve equations using something called the zero property, which basically says if a and b are expressions and a times b equals 0, then either a is 0 or b is 0, or they're both 0. So for an example, if you factored something like x plus 5 and x plus 2 and it equals 0, that means either x is negative 5 because that makes your first parenthesis 0, or x is negative 2 because it makes your second parenthesis 0. And that's all that these words mean up here and all the properties says. So what we're going to do is we're going to factor like we've been doing, and then we're going to figure out what makes our parenthesis 0 because that makes one of our factors 0. All right, here we go. This is the main part of your assignment today. Solve the equation. And we can't solve it unless we factor it first. So I'm going to set up my parentheses here. Don't forget your equals 0. So I'm looking for factors of 30 that would give me negative 11. And of course, the first thing that pops in my head for 30 is 6 and 5. And 6 and 5 is 11, but they both must be negative because 11 is negative. So I'm going to put x equals. Now, our answer is going to be whatever makes our parentheses equals 0. This first one says x minus 6. 6 would make that parentheses 0. The other one says x minus 5. 5 would make that parentheses 0. So there are two solutions. This one looks a little different, and it wasn't in the first part of the video, but one thing you need to know about factoring is the first thing you need to do when you factor is always look for GCF. Always look for the GCF first, which stands for greatest common factor. Both of these terms have an M, so I can factor out the M out of each term like that. And now that's factored, so I can put what my answer is going to be, what makes it 0. The number that makes the parentheses 0 is 7, so I'm going to put a 7 there. Now the M that's in the front, what would make that 0? Well, 0 would. As weird as that sounds, it's just 0. So two answers there, 0 and 7. And the last one is a difference of squares. This is what I was talking about a minute ago with difference of squares. It's got a z that has a square root. 121, whether you know it or not, does have a square root also, and it is 11. So you'd put z plus 11 and z minus 11. So your two solutions there are whatever makes the parentheses 0, which would be a negative 11 and positive 11. And there's that. Okay, last thing we're doing today is they're just changing directions on you. They're going to say find the zeros of the function by rewriting the function to intercept form. And we did intercept form the other day where we're just going to factor it, and that's it really. So what I'm looking for here is I'm looking for factors of negative 12 that add up to be negative 1. So 12 automatically, the first thing that pops in my head is 4 and 3 or 6 and 2. 6 and 2 will not give me a 1, but 4 and 3 does. So because it's a negative 1 in the middle, I need the 4 to be the negative 1 and the 3 to be positive. So that's it. That's intercept form. The zeros, another word for zero is x-intercept. So this is basically asking you where would you cross the x-axis? Well, you cross the x-axis at 4 and negative 3. Zeros are the same thing as solutions. Matter of fact, let me show you this next slide. If I could drill this in your head somehow, I would. When you see the word zeros, x-intercepts, roots, solutions, they're all related and really all refer to the same number. The last slide said find the zeros, which I told you were the same thing as the x-intercepts. The zeros are where the graph crosses the x-axis. Roots is another word for solutions. They all mean the same thing. And if you can get those 4 words and just understand they're all talking about the same number, then it's going to be much easier for you as we go. So that's all I got today. Hope it made some sense. We'll work on it tomorrow like we always do. Look forward to seeing you. See you. Bye.